so let me transition over into SolidWorks, and let's take a look at a design challenge that we're going to look at today. Typically, when you look at consumer products, oftentimes there's three kind of core areas you can kind of break things down into. One is the idea of the mechanical inner parts, right? These tend to be not terribly fancy. Sometimes they are. They tend to be mechanical in nature, so gears and mechanical kinematic designs, etc. Consumer product design also tends to be multidiscipline. So oftentimes you're not only trying to incorporate product design, but the mechanical aspects of a product design, but you're also trying to incorporate industrial design aspects. You're trying to incorporate electromechanical aspects, so circuit boards and controls and things like that. And then you're also aesthetically trying to incorporate what this thing looks like, the ergonomics of it, the more organic shapes that comprise the outside of the design. And so we're going to, kind of in that order, we're going to take a look at this specifically as it relates to a underwater sea scooter. This kind of a propulsion device for divers. And so let's kind of dive in. Again, if we take a look at the idea of just starting out with designing the internal design of this, what I hope to show you within SolidWorks is for those of you that are new to the product, hopefully you're going to get a good breadth and understanding of what SolidWorks is capable of. For those of you that are joining that have SolidWorks, hopefully you're going to pick up a few things you may not have known and a few things that maybe jog your memory a little bit around utilizing the software. But we're going to start out by just designing a gear cap around these gears. And what you'll notice is that as I'm designing in SolidWorks, much of what I need is right at my fingertips. I'm getting context toolbars that show up right where I am, getting inferencing lines to give me valuable feedback related to where I am in the design. I'm transitioning into a tangent arc right on the fly. And I've got this kind of just initial concept sketch related around what I want the housing of this gear cover to look like. I can add relationships. So this is kind of the concept of design intent, meaning I want the gear cover front to always be aligned with this bearing. And I also want the edge of the cover to be aligned as well. And then I can simply start adding in some relation to some dimensional data. So I want this to be 3 millimeters. I want this arc. I want that to be about 80. You're noticing as I'm keying in dimension, the geometry is updating to reflect what I'm keying in. I'll make this 50. So I've just initially done some quick line work related to a sketch that I'm thinking, this makes sense. This is what I'm looking for related to at least the general outline of this gear cover. Let's go ahead and take this into 3D, and I'm going to do that with a simple revolve. What a revolve does is it basically is you're going to take that and it's going to manipulate 360 degrees. And what's great about SolidWorks is that I'm able to basically key in the thickness right from the property manager. So over here on the left, I'm just going to key in that I want the wall thickness to be 4 millimeters. And I get the live preview so that I can see this is exactly what I want and it looks good. Right, so in a matter of just a couple of seconds here, we've been able to just kind of create a basic sketch of what we want and spin it around 360 degrees and get a cover for our gears. SolidWorks provides a huge depth of visualization capability, so I'm going to change the transparency just on my right mouse button so I can see what's going on inside this design. A part of design is being able to ensure form, fit, and function, and one of the great ways that we can do this is through continuing to design this cover right in the context of the assembly. So what I'm going to do here is with just a shortcut key, with Tab, I can hover my mouse over this part and I can make it disappear. And what that does now is it allows me to start a new sketch back on the face of the motor housing where I can easily pick the edges that I want to utilize. So I'm just going to pick these 4 circles and I'm going to use our convert tool to bring them into the design. Now just as easily as hiding it, I can hit Shift Tab and it brings the part back right into visibility. So that, again, just kind of touching on some of the visualization tools, being able to very quickly hide or remove parts so that I can grab the geometry I want. And I'm going to be able to ensure that this design fits very nicely because I'm leveraging the sketches right off the motor housing. This is a little bit of a complex, at least shape related to where those need to terminate. And what's nice about this is I can simply tell SOLIDWORKS to terminate the bosses where it finds the inside face of my gear cover. Again, the depth of the commands allow me to add thickness to those right on the fly. So we're going to make those about 2 millimeters in thickness. And I can even incorporate things related to manufacturability. So I know that I'm going to need to make sure that I have draft on these parts as well. So again, one command, and I'm creating all the bosses I need. I'm adding the draft, and I'm adding the thickness to the part right out of the gates. Right, so now I'm able to ensure form. I'm able to ensure fit up to the motor housing, which is great here. Let me just show you though as well that we can open this up in its own window and maybe just interrogate it a little further. Right, so now I'm able to rotate around just this part. I'm able to apply things like material, so I can get realistic material capabilities, and then even evaluate things like mass properties. How much does this weigh? What's the volume? You know, how much plastic am I going to use in creating this part? Ultimately, though, let's go ahead and create this. Let's document this as a drawing. So I'm going to just simply create a new 2D drawing. Pick the template I want. And just drag and drop some views right onto the screen. So I'm going to take my front view and drag it out there. As I move my mouse to the left, I'm going to get a left side view. As I move it up to the right at an angle, I'm going to get the isometric view that I'm looking for as well. Sometimes designs like these, though, it's quite helpful to be able to see the cross-section, right? See what the design looks like if we were to section it. And with the view layout tools, I can easily create a section view of my design as well. In this case, I'm going to do an aligned section. And the SOLIDWORKS tools allow me to just real cleanly and easily walk through this. I'm just going to basically just pick some references for where I want to section this view. You can see that there's a little bit of noise, if you will, edge lines in the background that are just, it's true representation of the geometry, but it makes the view just a little confusing. And what's nice is that I can come over here and just say, you know what, I only want to show the faces that I'm cutting with the section. It just nicely cleans up a lot of the background geometry so that I get this nice, clean, aligned section view through my design. And ultimately, we created this with a fair amount of dimensional data, and I can bring that, that data in. I can just say, you know what, all the dimensions that I used to create this part, I want to bring them into that section view. So those dimensions come in. I can position them on the screen where I want them. So we can make sure that it's clear for anybody looking at the drawing that we get exactly what we want. So that looks good. And then likewise, we picked up some references off of other geometry that don't have dimensions. And what's kind of nice about SOLIDWORKS is that I can simply go in and just start picking edges and pieces of geometry that I want to add a dimension to, and that's well and good. But what's also nice, though, is that with the dimensioning tool, I can auto-dimension. And auto-dimensioning effectively allows me to pick some datums. So in this case, I want to just select the center of this circle. And I'm going to tell it that I want to just box select around some entities that I'm interested in adding dimensions to. And we'll go ahead and hit apply. And SOLIDWORKS does a great job of going ahead and adding some additional dimensions to my drawing, including things like quantity callouts, which is quite nice. And I'm left to just go ahead and position the dimensions where I want them. And that looks good. Ultimately, maybe this drawing is just to communicate a concept, right? This is roughly what we're thinking. We want to get some feedback, maybe either from a manager or from a customer, say this, or even a manufacturer of this part, and say, hey, what do you think of this so far? And eDrawings becomes a great tool for communicating that design. So just with a single menu click, I can publish this to an eDrawing and elicit feedback from either others in the organization or outside the organization. If you're new to eDrawings, what's just kind of nice about this is I can select a view, even though this is a 2D drawing, I can select a view of like an isometric, and it becomes the 3D model. Right? So I can rotate this around, I can look at it, I can section it, I can do a lot of great things with this design. When I'm ready to go back to the drawing, I can just simply hit home. Likewise, I can also provide feedback, as I mentioned. And so what I'm going to do here is, maybe from a manufacturer's perspective, he's looking at this and saying, man, we really need to put some rounds in this if it's going to come out of the mold okay. So he can make a note, and maybe someone else in the organization, maybe my boss or someone who's looking at the overall design, the overall system design says, you know, we're going to need bearing supports. Right? So everything is time-stamped. It indicates who said what, when they said it, etc. And you know what's quite nice about this is that I can just come in and say I want to save the markup for all the reviewers. And I'll just throw it out here on the desktop so I can find it. So I'm going to save the markup and close out of eDrawings. And so we've had kind of this collaborative environment where others are providing feedback on the design. But as an engineer, as a designer, I need to kind of pull all that feedback together into a spot where I can actually, you know, see how it overlays. And one of the great things about the new interaction between eDrawings and SolidWorks is the fact that I can bring in an eDrawings markup file. So I can say, you know what, that markup that everybody just sent me, I'm going to take it and I'm going to bring it right onto the SolidWorks drawing and lay it over the top. And so now, as an engineer, as a designer, trying to make this all happen, I can say, oh, okay, I forgot the bearing supports. It's going to be key to this, obviously. My manufacturing person is telling me I need some fillets in there so that this gets out of the mold okay. And all these markups, including who said what and the comments they made, get listed over here in the property manager. This becomes just a really great way to collaborate on the design back and forth. So with that, let's just go ahead and remove those since we now know what we've got to do. We'll go back into our gear cover and let's just start making some of those changes, those design changes. So manufacturing person, they're asking for some fillets. Oops. Let's go ahead and add those in. In this case, we're just going to do a 0.7 millimeter fillet. And the selection tools in SolidWorks are great. I can simply just pick the face that I want. SolidWorks is going to grab all the edges associated with that face and run the fillets around not only the bosses but the inside edge here as well. So that's the first thing we needed to accomplish. Let's go ahead and just save this and close it. The second thing that we want to accomplish here is being able to mount the bearings for our gears. And so let me go ahead and make this transparent again so that we can do a little bit of work here. What's again nice about this is that I can just simply pick what I want to use here and do a right click. I'm going to just isolate these components that I want to work on, right? So with a right mouse button click, we can go in and say isolate the components. And now that they're isolated, I'm able to just work on those components. So the first thing we're going to do is we're going to start a sketch back here on the inside face. And I want to just place some reference points that allow me to pick up the location of where my gear bearings are. Right? So we'll come in here and let's just add a couple key points. We'll put one here, put one here, and one there. Right? So that just gives me some reference points, and you're going to see why those come into play here in just a minute. But now that I've been able to quickly pick up the points that I need, I can exit the isolate command. Everything comes back the way I like it. And let's take a look at actually adding in those gear supports. And this is where our design library comes into play. I can have standard features that I might use quite often and just make them available so that every time we design something that uses these bearings, I can simply select it, pick the size I want. SOLIDWORKS prompts me and says, hey, let's where do you want to locate it? And that's where the sketch point is come into play. Let me change the transparency on my drawing here real quick. So I'll do 9 millimeters, and let's locate it here. And let's also go ahead and accept that. We'll place another one in. And then we'll place the final one right in the middle. So. Right, so now I've got all my geometry in place. It looks good. It's going to support the bearings the way I want, and I've been able to reuse design criteria as well. Now, so that kind of gives you a sense of oh, and let me point out one other thing. Obviously, all these design changes are being tracked on my drawing. So when I come back to my drawing, all my views are updated to reflect the rounds as well as the gearing, the spots that I want to put the bearings, and that becomes just a really nice way of ensuring that part assembly and drawing are all being updated and tracked together. It keeps track of the bookkeeping, if you will, for you. Okay, so the other piece of this, typically, as I said, is that consumer product design tends to be multidisciplinary, meaning that as I'm designing, there are other parts of this, typically like circuit boards and things like that, that I may need to incorporate. And with SOLIDWORKS Premium, we have the ability to actually read in IDF format. So if you have a circuit board designer either in-house or someone who is that you contract to do this, you can actually grab their PC board design. And here I've just mocked in just an initial the initial kind of blank for the circuit board. But with CircuitWorks, I can actually bring it in with full fidelity. So they provide the IDF file. I'm able to read that in with CircuitWorks and then leverage it fully. So once it's read in, I'm going to go ahead and just do a replace component on the one that I mocked up, browse for the design that I'm looking for. And this one's going to be a full assembly with all the circuit components. And hit OK. And now I can actually replace that with the circuit board with geometry representations that reflect what I'm doing. And now it becomes quite nice because I'm able to actually understand volume, right? Am I going to have another part of my design affecting this running into the circuit board? The other nice thing about CircuitWorks is it takes into account things like keep out areas. A lot of times your circuit design softwares are going to have the ability to dictate volumes that are keep out areas because of heat or whatever else it may be. Those can all be brought into SOLIDWORks so that an engineer or designer can make some really good decisions about what they're doing from a design standpoint. And what you'll notice here is I'm just using configurations. Again, I like to really point out the fact that from a visibility standpoint, we're able to have a lot of options, making sure that I'm seeing and working on exactly what it is that I want along the way. So we looked at the second piece of this that I outlined, which is this idea of designing the inside of the design, multidisciplinary actions where you've got electrical components and circuit boards coming in. The last piece of this is now how does this come into play with like an industrial design? Or now I want to actually create some very organic shapes related to the outside of this design. So one of the great things that SOLIDWORks allows us to do is it allows us to take an industrial designer's sketch and actually bring it in directly into what we're working on here so that we can take a concept and build off of it in the design. So here you can see that I've just got a 2D picture that maybe a concept artist or an industrial designer or someone has provided me. And I'm now, effectively tasked to say, okay, we gotta make this a reality. This is what they're looking for. How do we go about doing this from a product design standpoint? And there's lots of ways that we could accomplish this. We could use surfacing, we could use solids. The approach that I'm going to take, just to kind of show you the depth of the features that we have, is to use a solid-based method. But just realize that we have a full surfacing suite as well that open up a lot of other doors in the design process. So let's take this, and again, we're going to just do like we did before with the cap and actually start designing right in the context of the assembly. And what becomes good about this is not only am I able to just pick up some key points that I'm seeing in the artist's sketch, but I'm also able to reference the design components that I've already started with, right? The housing, the battery, etc. And so let's just add a few dimensions to this. SOLIDWORKS does not require us to add dimensions to sketches, but you know, it does become kind of nice to at least control some aspects of it. And we've got some curvature along the top, and so we're going to just use a 2-point spline. We'll come in and just connect these 2 points together. And a spline then, the 2-point spline has drag handles. Now I can just start manipulating, pushing and pulling on that profile, even adding relationships. So I always want this spline handle to be horizontal so that I get a nice clean arc. And maybe this one I just want to further just tweak a little bit to map at least an initial curvature. I'm trying to come up with a good balance between what the industrial designer is asking for and obviously the mechanical constraints of what I've got going on from a propeller standpoint, the motor housing. So I've got a profile that I'm happy with. Let's go ahead and just revolve this 360 degrees. Right? So I've got a profile, simply going to pick an axis that I want to revolve about and then hit OK. So I've got the kind of the tail end of this design completed. Now the same thing holds true with the front, and what you're going to see me do, just for the sake of time, because we're going to repeat a lot of the same types of actions. I have some sketches created just to facilitate through the presentation here. But here you can see I did the same thing on the front. It's highlighted in blue. It's just a simple 2D profile sketch where I'm mocking up or matching to the best of my ability what's being asked from a concept standpoint. And I'm going to simply revolve that as well. I'm going to pick a reference to revolve about and then hit OK. Now, this is a pretty bulky transition. I think we would all agree that anybody who would be looking at this in the store would be a little concerned about our design at this point, and probably our company would be as well. So let's smooth this out, and I'm going to start by just cutting away some material. I'm going to start a sketch. I'm going to leverage the profile again with that convert entities command, and I'm going to cut away the geometry in the middle. Right, so we're going to just pull this away. We'll do about 70 millimeters here, and get rid of the middle portion of this geometry. Okay. Now, what's nice about this is that I want to create a very organic loft between the two, and so I'm going to grab the loft command in SOLIDWORKS. And what I appreciate about this is I don't have to sketch anything. I can just simply pick the edge of this geometry and the edge of this geometry here, and it starts lofting between the two. Now, consumer product design often gets into curvature continuity, right? I become concerned about how the light and shadows reflect off the design. I also become very interested in how it feels to an end user. For many of you, just so we have some at least baseline, right? Curvature continuity is a level above tangency. And the benefits of curvature continuity in a design is that you, in a tangent situation, if you rub your thumb over the top of something that's just purely tangent, a lot of times you can feel a bump. Actually, it affects the aesthetics and how it feels. With curvature continuity, you can actually, you're representing a blend or a radius with a spline, and it creates a situation where it becomes much more harder for an individual to feel the transition. And what's nice about the loft is we can capture this with start and end constraints. So I can come in and say, the start constraint, which is the first edge there, I want to come off curvature to face. So it's gonna come off of here, and you can see initially it's most noticeable right down here at the bottom that I get this nice transition occurring right off that first edge. And I can do the same thing with the second one. So I'm going to say I want this to be curvature to face as well. And so as it starts to blend back into the second piece of geometry, it creates this really smooth transition between the two that when we hit OK, we can see that now we've got this really nice looking design that's really starting to match what our concept designer had intended. Just so everybody's aware, if you do get into curvature continuity, we provide some nice tools related to things like zebra striping. This actually mimics the effect of having a highly reflective surface with bright lights on them. And in fact, this is kind of a fun thing to see. The next time you get your car washed and you go into the gas station and they've got the lights on, you can actually see this effect a lot of times in your car's reflection. This idea of how the reflection and the shadows blend across the different faces on your vehicle. So we've got some nice curvature continuity, so let's go ahead and turn that off. So again, just to facilitate this idea of this design and the presentation, I've got a nice sketch already created that mimics the tail ring back here. And the approach that we're taking with this design, many people might call this a master model approach. We're creating all the geometry for this design so that at a later point, we can go back in and we can slice and hack it into individual parts that can actually be manufactured. All right, we'll walk through that here in a little bit, but so here you can see I've got the tail ring. We need to create this fin. And so let me walk you through the sketches that I've created for this as well. Again, we created a lot of these sketches, so I think you get the idea by now, the idea of sketching, right? And what I have here is a sketch that represents the profile of the fin, and then I have a path that represents, at least the initial trajectory of the fin. And then I have another sketch that represents a guide curve across the top. What this does then for me is when I go to sweep this, I'm going to pick a profile, which, as I mentioned, was right here. I'm going to pick my path. And again, SOLIDWORKS gives me this great initial preview. And then I'm going to add in a guide curve. And the guide curve is basically saying, listen, as I transition from point A to point B along the path, I want it to be influenced by the guide curve, right? So it manipulates the cross-sectional profile as it transitions along the path to ensure that it stays connected to the guide curve, and you end up with some really, really nice geometry when all is said and done. All right, so we've got the fin created here. We can hide those sketches. And I want to have 4 of them equally spaced around the outside of this, and so I can do that as well. I'm just going to do a circular pattern. I'm going to grab just a reference. The reference can be geometry, so I'll just pick a cylindrical reference, and I'm going to choose the bodies that I want to pattern, in this case the fin, and let's just put 4 of them equally spaced. Now, at this point, we can go ahead and turn off the artist's sketch. We're not necessarily need that at this point. But another thing I want to point out to you is that SOLIDWORKS is forgiving related to your design. So specifically, when I created this fin, and before I patterned it, I wanted to create a bullnose fillet across the top. And SOLIDWORKS is great because it allows me to actually just come back in time. So I'm just going to roll back before the pattern. I'm going to add the fillet in. In this case, I'm going to do a full round fillet, and I'm just going to simply select the faces, so the side face, the middle face, and then the adjacent face. And SOLIDWORKS does a great job of just blending over the top, right? I get this really nice, clean bullnose fillet, if you will, across the fin. And Once that's been added, if I simply roll back down through the feature tree, right, to where the pattern was, SOLIDWORKS updates all the fins to reflect that bullnose fillet that I put on the fin, which is nice. So again, you've got flexibility because there's a feature tree that at any time I can go back to a given point and adjust the design criteria or fix something that I may have left out. Now, we've got to have a situation where somebody can actually hang on to this. And so let's turn on a couple handle sketches that I brought up. Again, I introduced the sweep to you with the fin. Same thing is going to be held true here. I've got a profile and a path. And let's just go ahead and sweep that profile along the path. And you know, immediately it becomes pretty obvious that we have a challenge here. No one's going to be able to grab onto this comfortably based on where these fins are. You know, that becomes pretty apparent. And so what we'll do is let's just make a design change. We want to take those fins, and in this case, I'm going to just move them. So we'll say that we want to move or copy them. I'll just select each of the fins. And we'll rotate them around. Just spin them around about 45 degrees. About right there. And hit OK. When we do this, now it really nicely opens up the inside of the handle, right? So somebody can actually get their hand on there and grab onto it. Now, the last piece of this really is about ergonomics. You've got this really, really great, smooth-looking design, and then we've got a less than stellar handle, right? It's functional, but it just doesn't look real great at the moment. Simple, and so one of the things that we can do in SOLIDWORKS is we can utilize our Flex tool and really, start to sculpt this handle into something that looks quite nice. So I'm going to grab the Flex command. We'll grab the body of the handle. I'm going to say that I want to twist it. And so with the twist, I can grab onto the plane up here, and you'll notice that I can just start tweaking the geometry so that it looks quite, a lot more ergonomic related to what I want. So that looks about good right there. I'll say OK. So I've taken this simple piece of geometry, I've grabbed onto it, and I've really sculpted and tweaked it so that it now becomes something quite nice that I can grab onto and is going to feel good in someone who puts their hand around it. With that done, then we can just simply go ahead and mirror it to the other side. I'm going to pick a plane that I want to mirror about and select the geometry I want to mirror. Hit OK. Now I've got the other handle on the other side. Last but not least, the way I've been accomplishing a lot of this is through what we call multi-body design, the ability to kind of segment out chunks of the geometry so that I can work on it individually. But at the end of the day, I need to combine this all back together into one nice, clean design. And so I can do that. I'm just going to take all the bodies that I have so far, and I'm going to combine them back together. And the benefit of combining them back together is now I have one consistent chunk of geometry, but the reality is that it's not manufacturable at this point. In fact, if I turn on the section view, you're going to notice that it's solid all the way through. So obviously that creates a situation where we've got interferences, not to mention that it's not going to be very clean to try and create, or at least cost effective. So one of the things that we'll do is we'll just take this and we'll shell out the geometry. So I'm going to just tell it that I want to make the wall thickness about 2 millimeters, and then we'll go ahead and hit OK. And now what SOLIDWORKS does is it basically says, OK, great, I'm going to take that whole chunk of geometry and I'm going to add a 2 millimeter wall thickness to everything. So now I've got some really nice cavities, some nice looking geometry in there. I can affirm that everything fits nicely. Right? So I've taken these multiple disciplines, I've combined them together into an environment that allows me to validate the design is going to work correctly. And the last thing now that I have to do is just start to focus in on some manufacturability. Again, we're using this approach of, it's often referred to as the master model design. And this creates a lot of benefits because it's a lot easier to design this as one consistent solid than it is to try and design the individual pieces. But at some point, we've got to be able to break them out so that we can manufacture these. And so what's nice here is I'm simply going to just draw some sketch lines roughly through where I'm interested in kind of breaking this design apart, build some relationships, so we'll make this make these coincident. And I can use combinations of things to split this apart. So once I've got the sketch, I can use sketch geometry, I can use surface geometry, whatever I need to make the split. And so using our features here, specifically the split command, this is where I start to be able to break this up into its individual components. And I'll tell it to cut the part. So I'm using two pieces of sketch geometry and a surface that I have back here. I'm going to tell it that I want to keep all these. And actually right here within the dialog, I can also save them out as individual part files as well. But the idea here is now I've split this design, and with it being split, I can, let me just move these for you so you can see. Now I've got the individual components that can be manufactured, right? So now I have the each of these, which become a lot more easier to build tooling around, etc. And as I said, I can save each of these out into their own part file, which then allows for cores and cavities to be made. It can be sent out to different manufacturing facilities, etc., to get quotes on and things of that nature. And so you kind of get the sense, hopefully now, of how SOLIDWORKS, from the standpoint of consumer product design, really starts to become a great tool for doing this kind of work, not only because of the depth of the design tools that are there, but because we can really start to leverage these other disciplines in our design and design around it. And then ultimately with this design, you know, we may want to communicate it to look to communicate it to others, and so we can render this design out as well, so that people can see exactly conceptually what this might look like. And so, you know, putting some backgrounds, some decals, etc., on the design, so that people really conceptually start to understand what this is going to look like. So again, hopefully, as I said, if you're a SOLIDWORKS user, you hopefully picked up a few tips or tricks or a few things that maybe you didn't know. If you're new to SOLIDWORKS, hopefully you kind of understand the depth and the capabilities that SOLIDWORKS provides, not only, again, from a design standpoint, but communicating the design as well, whether it's through rendering, through 2D drawing, or the 3D model itself. And so with that, we're going to kind of wrap things up and allow some Q&A. And so I haven't seen too many questions come in through the